In the grand theater of late 19th century physics, the final act seemed to be drawing to a close. The magnificent edifice of classical mechanics, built by giants like Newton and Maxwell, stood nearly complete. Physicists, filled with a confident pride, believed they had tamed the universe, with only a few minor pesky clouds lingering on an otherwise clear horizon. But one of those clouds was about to unleash a storm that would shatter the very foundations of their world. It was a seemingly simple problem, emanating from the gentle glow of a hot object. This puzzle, known as the blackbody radiation problem, centered on a profound disagreement. When scientists measured the spectrum of light and heat given off by a perfectly absorbing and emitting object, a black body, the results made no sense. Their trusted classical theories predicted an absurdity: that any hot object should blast out an infinite amount of high-frequency, ultraviolet light. This glaring failure, famously dubbed the ultraviolet catastrophe, was more than just a minor anomaly. It was a deep, conceptual crisis that left the greatest minds of the era completely stumped. Into this intellectual impasse stepped a quiet, meticulous German physicist, Max Planck. A man deeply rooted in the classical tradition, Planck found the blackbody problem profoundly unsatisfying and dedicated himself to solving it. He wrestled with the equations for years, trying every conventional trick he knew. But the elegant laws of classical physics refused to cooperate with the stubborn reality of experimental data. Finally, in the closing weeks of the year 1900, driven by what he would later describe as an act of desperation, Planck made a revolutionary leap of faith. He proposed a radical, almost heretical idea. What if energy wasn't the smooth, continuous flow everyone assumed it to be? What if, instead, it was emitted and absorbed in tiny, discrete packets? He called these individual energy packets quanta. This was like suggesting that one could not simply walk up a ramp, but had to climb a set of stairs, one distinct step at a time. From this audacious assumption, he forged a new equation, E equals hv, a formula that would become the cornerstone of a new physics. The result was nothing short of miraculous. When Planck applied his quantum hypothesis to the blackbody problem, the theoretical curve snapped perfectly into place, flawlessly matching the experimental measurements. The ultraviolet catastrophe vanished. The puzzle was solved. Yet Planck himself was deeply unsettled by his own creation. He was a conservative at heart, and initially hoped his quanta were merely a mathematical fiction, a clever accounting trick to make the numbers work, rather than a description of how nature truly behaved. He could not bring himself to believe that energy itself was fundamentally lumpy. But the quantum genie was out of the bottle, and it could not be put back. A few years later, a young and then unknown patent clerk named Albert Einstein took Planck's idea and ran with it. Einstein showed that light itself wasn't just emitted or absorbed in packets, but actually traveled through space as particles of energy, later called photons. His explanation of the photoelectric effect provided the first independent confirmation of Planck's quantum, proving it was not just a trick, but a fundamental feature of reality. This confirmation cemented the dawn of the quantum age, but its father remained a reluctant revolutionary. As the years passed, Planck watched with a mixture of pride and alarm as a new generation of physicists, including luminaries like Bohr, Heisenberg, and Schrödinger, built upon his foundation. They unveiled a bizarre new world governed not by deterministic certainty, but by chance and probability, a strange, counterintuitive reality that Planck, the man of the old school, never fully embraced. Despite his personal reservations and a life marked by immense personal tragedy, including the loss of his children to war and misfortune, his monumental contribution could not be denied. In 1918, he was awarded the Nobel Prize in Physics for his discovery of energy quanta. Max Planck, the cautious revolutionary, had sought to mend a small crack in the structure of classical physics. In doing so, he had unintentionally swung open the door to the quantum realm, forever altering our understanding of the universe and our place within it.